Hello, it is Dr. Hakan Satiroğlu, and we have fourth tutorial on business analytics. In our fourth tutorial, we are looking at predictive analytics, and forecasting. I would open by saying that prediction becomes valuable only when it improves a real decision. Students often get excited by model. In practice, a forecast or prediction is useful only if someone can act on it. A business may forecast demand to plan staffing, predict churn, or to target retention, or estimate waiting times to improve service. In each case, the output matters because it helps choose an action earlier. I would also stress that prediction is not certainty. It is a structured estimate of what is likely based on patterns in the data. Also, I need to underline that predictions are based on some prerequisite investigation, like normality check, heteroscedasticity check, residual checks, after it start to make sense. That is an important teaching point because students can otherwise think the model should be treated like a fact. It is actually a forecast, and a good forecast can still be wrong, especially when the environment changes. So this session should teach both possibility and caution. This tutorial introduces predictive analytics and forecasting. I would open by saying that prediction becomes valuable only when it improves a real decision. And I would explain that decision is designed to move from framing the target to evaluating the output. I would tell students that by the end, they should be able to choose between broad prediction types. Think about basic forecasting logic and explain why validation matters. I would also make clear that this tutorial is not mainly about advanced mathematics. It is about decision-oriented reasoning. For example, in one context, the manager may need a number, such as next week's demand. In other contexts, they may need a category, such as whether a customer is likely to leave. These are different predictions and different prediction characteristics and shouldn't be mixed up. Setting that distinction clearly at the start helps students stay grounded. It also reduces the fear that predictive analytics is only for specialists. The core thinking is accessible if this business question is clear. Start from business target and predictive workflow. Here, I would like to walk students through the predictive workflow. We began by defining the target clearly. If you don't define target, it's really difficult to see what is the performance of business analytics or forecasting. Then we gather useful inputs, choosing an approach, validate performance on unseen data, and plan how the result will be used. I would stress that the business target must come first. If the target is vague, the later model will also be vague. A practical example is student dropout risk, let's say, or customer churn, or weekly product demand, each one needs a clearly defined outcome and a clear time window. I would also explain that the workflow doesn't end with a metric score. The prediction has to fit into the decision process. Who sees it? What do they do with it? Is that a human review step? Those questions are important because predictive analytics is not only about building a model, it is about embedding forecasting into real operating system. Hard and soft elements must travel together at this point again. The hard side includes target definition, characteristics thinking or feature thinking, model choices, forecasting basics. The soft side includes explainability, trust, realistic use. I would explain that a highly accurate model may still be unsuitable if managers cannot understand when to trust, or if the process around it is weak. For example, may predict patient no shows quite well, but staff still need clear rules about how that prediction should influence scheduling. This is where judgment matters. I would tell students that responsible prediction means asking not only how accurate is it, but also how will it be used and what happens when it is wrong. The question opens up practical and ethical thinking without overwhelming the class and technical language. I will explain the difference between regression and classification in simple terms. Because mainly we do regression in forecasting. If the output we want is a number, such as revenue, waiting time, or demand, we usually use in regression style problem or model. If the output is a category such as leave or stay, approve or reject, high risk or low risk, we are in a classification style problem. So it is important to see what kind of problem exists or try to solve. I would tell students that this distinction matters because the business decision change with it. Predicting exactly sales is a different task from flagging which customers are high risk of churn. A professional experience example is insurance. Predicting cost of claim is different from classifying whether a claim may be fraudulent. This slide is really about matching the analytics method to managerial question. Once students understand that, the rest of predictive analytics become much easier to teach. Time series forecastings. I would present it as pattern recognition over time. Students should look for trend, seasonality, cycles, and unusual shocks before trusting a forecast. I would use an example they can easily picture, such as retail demand increasing before holidays or transport usage dropping during the disruption. The point is that time itself carries information. Yesterday and last year can both matter, but in different ways. I would also warn students that forecasts become weaker when the environment changes suddenly. A clean historical pattern can break after a policy change, supply problem, or a major event. So I would encourage them to treat forecasting as a support tool, not an oracle. In practice, many good managers combine forecast output with contextual judgment, especially when unusual events occur. The balance is an important professional lesson. Third technique, validation and explanation. Here, I would like to explain that evaluation is just important as model choice. Students need to understand that different business problems require different performance measures. If false alarms are expensive, one metric may matter more. If missed cases are risky, another may matter more. For numerical forecast, we may care about average errors. For classification, we may care about how well the model identifies the right cases. I would keep the language simple and focus on the cost and consequence. A fraud model, for example, can tolerate some false alarms if missed fraud is very expensive. A customer marketing model may need a different balance. I would also mention explainability if a model influences an important decision. If the organization should be able to explain the logic in a sensible way. This helps build trust and makes the output easier to manage in practice. Workshop pitfalls. I would use this activity to move students away from the idea that the main task is to build a model. Instead, I want them to design useful decision aid. The prompt asks them to choose a context, define the target, choose evaluation measure, and state one rule for human review. That last part is important because good predictive analytics usually includes a safeguard. In the brief, I would ask whether their target is precise enough, whether their metric matches the business costs of error, and what should happen when the prediction conflicts with common sense. That helps students think like responsible professionals rather than only like model builders. I would close by reminding them that prediction is valuable because it supports action under uncertainty. But it works best when the process around the model is a careful design as the model itself. Thank you very much for listening for tutorial.